Okay, so this is a bit of a different question in the fact that you're not solving for one variable. You're solving for two variables in which you have a ratio of those two variables. So that's what we want to do right now. Okay. So it says, what is the charge to mass ratio for a particle accelerated to a velocity of 6 meters per second? So, I have a velocity of 6 times 10 to the 6 meters per second. And it moves in a circular path of radius. There, perpendicular and uniform into a magnetic field of that. Okay, so what you're doing is you're using two force equations. So all I'm going to focus on is not this stuff right here, but the force equations. So the first one is mv squared over r. Okay, so mv squared over r is the centripetal force going around a circle. All right, we've done work with that. So that's the centripetal force around a circle. The second equation that we're going to use is BQV. So I have the velocity. So that's the F equals BQV, which is the maximum force in a magnetic field in which a particle enters it at a perpendicular to the lines of force. Okay, so what I want is, it says it wants the charge to mass ratio. So on one side of the equation, I need to get the charge over the mass. So what I'm going to do first is I'm simply going to divide the mass down. I'm going to divide that mass down. So that's going to give me v squared over r equals b q v over m. Okay? So again, it's just some algebra work here. Now I need to just leave q over m because that's charge to mass. I need to get rid of the b and the v. So that's v squared over b, v, and r, and that's equal to q over m. So q over m is my charge to mass ratio. This v squared divided by that v. So now all I'm left with is my v, which is 6 times 10 to the 6 meters per second, divided by these two right here. All right, so put that into my calculator, 6 exponent 6, divided by 0.018 times 3 part 2 times 10 to the negative 10, or 10 to the positive 10, sorry. Charge to mass ratio. So coulombs per kilogram. Okay, so the part that is significant is in here, is working with centripetal force versus the maximum force in a magnetic field, and letting those forces equal each other. Okay? Comments, Rory?
No, I think what really screwed me up was having to have like the charge over the mass.
Yeah, we don't do that very often. I think there's maybe been one other time in all the physics that we've done where you've compared the Q over M. We did that with volt per meter in one of your electrostatics assignments. But other than that, we don't normally do this where you leave two variables on the same side, and then we solve for the two variables. All right. Any of the other questions that you want to look at?
Not at the moment, no. That was the only, like, I don't know, like, I just can't figure out the formulas. That's what really gets me after, like.
Yeah, I understand that. So the best thing you can do is just kind of, the only thing I would have done maybe, Rory, is added on this formula sheet that I gave you, this new one, is add that mv squared over r is equal to force. Add it in the bottom right corner below that BEV.
Okay.
And then you may also want to add, for that one question in which we do work is equal to kinetic energy, right? So work is equal to charge times voltage, and excuse me, thank you. Kinetic energy is equal to 1/2 mv squared. So you may want to add those two just to that sheet. They are on your other formula sheet, but you might want to add them to this one.
All right.
Okay. Any other questions out of those? What you may want to do is, although I don't know, the answers are there, is peruse through that number 6 at some point today. I will give you an assignment on Friday to wrap this section up. And then Tuesday next week, I will start work and energy, which I've got to photocopy and send to you guys. Okay?
Can I be that somehow? My mom's getting mad because I have to significantly out of my own.
Well, I can just leave a textbook out front of the school.
Yeah, that might work better. Thank you.
Okay, I will do that. All right, anything else, girls?